Hello! Welcome back to Dark Dragon Does Math. Let's get down to some math. Alright. Here we go. Alright, so I'm going to talk about the vocabulary for 7.3. So the first vocabulary term is simplify. Now to simplify something, we're going to write an equivalent expression by combining like terms. So that's in 7.3. Simplifying can mean a lot of different things, and in this instance it just means to combine like terms. For example, if I were to say x plus 3x, and I were to simplify this, I would say, well, I have 1x, 2x, plus 3x is here, so I have a total of 5x, and I've just simplified this expression into a different expression. And really this signifies all these other terms. So coefficient. A coefficient is the number in front of a variable. So the number in front of this variable is 5. That's the coefficient. That's the coefficient here. Now, if I just have x, it has a coefficient as well. It's just hiding. It's a sneaky little understood 1. Okay? So if I said 7x, the coefficient is 7. So that's coefficient, and that comes into play a lot more next chapter. So like terms. Like terms is where is a term or terms with the same variable in the same exponent. Now in 6th grade, most of the exponents that we use for like terms are mostly going to be say to the first power, which we again don't write. It's understood that it's there. But we might see, say, x squared, or we might see x to the third. I doubt that we'll see much higher, but as long as they are the same variable, which is the x, and the same exponent, which is a little number at the top, they can be combined or simplified. So what I mean by that is 2x and x are like terms. Let's move that up. 2x and x are like terms. 4 and 6 are like terms. There is no variable, so we don't really have to worry about them being the same variable, but they do have the same exponent, which is an understood 1. X squared and 4x squared, well, these are like terms. We could combine these. If we were to combine these and simplify them, it would be I have 4x squareds here and I have 1x squared there, so that is 5x squareds. An example of something that's not a like term is you could say 3y and 3y squared. Those are not like terms, and we'll probably get into a little bit of this later, why they're not, but just understand that the letter has to be the same, and then the exponent has to be the same. If either one of them are different, they're not like terms. Now, so an equivalent expression is an expression, expressions that are equal for all values of the variables. Expressions that are equal for all values of the variables. An example of this would be this right here. No matter what x is, I have 5 x's here and I have 5 x's there. So the value of that would be the same no matter what. So that's kind of the gist of 7.3 in terms of vocabulary, and we'll get to some examples in a bit. Thanks. Oh wait, hold up. Yay!